Hello everyone, welcome to the channel. Today's topic is reinforcement learning. We'll look into what is reinforcement learning and also reinforcement learning with human feedback. Then we'll recap the topic and interesting AI RL skill test at end of the video. Don't forget to take the test. Let's get started. Reinforcement learning is a machine learning algorithm. In this, machines, robots, AI agents learn and make decisions through trial and error. A machine, robot or an AI agent performs actions, receives feedbacks and improves over time. The feedback loop has reward and penalty. Reinforcement learning learns optimal strategies from experience. RL is used in games like AlphaGo, robotics. For example, autonomous vehicles like self-driving cars find the way by observing the roads. Computers, robots playing chess make movements based on opponent action. In the self-driving car or chess game, reinforcement learning uses rewards and penalty techniques. Reinforcement learning, short form RL, can plan for future. Let us look into the technical details of reinforcement learning. Reinforcement learning is time-based function with feedback loop. What is the meaning of time-based in reinforcement learning? Imagine a self-driving car simulation. At each point in time, machine can decide what to do next. Accelerate, apply brakes, take left turn or right turn. There are 6 key components to understand reinforcement learning. Those are state, agent, reward, penalty, environment, and policy. Let's look into each of these terms one by one. Starting with agent. An agent is a learner. Agent can be a machine, a computer, or a robot. State is about current situation or current position. States, actions, rewards help us describe how the agent and the environment interact. State is for each location. That is, in chess game example, is there any obstacle for king or queen if I make a move in a particular direction on the chessboard? In this example, an agent or computer program will learn about the chess game and the movements. Action is what machine does in environment by observations. In the given situation, what choices an RL agent can have? In a self-driving car, if a road is blocked, what choices an agent can have? Wait till the roadblock is cleared or take a different route. If you are a software programmer, then you must be familiar with maze problem or treasure hunt problem. An agent moves in the maze, the square boxes randomly to find an exit route from the square boxes. If RL agent reaches exit route, then reward. If RL agent hits the wall and does not reach the exit route, then penalty. The robot or RL agent tries different routes and learns the shortest path to exit from maze. The robot learns from trial and error and finds the optimal solution to exit from maze. In this maze problem, total number of routes for an agent to exit is say 20 routes. So states are 20. Actions are directions in which agent can move left, right, up and down, 4 directions, block by block at a time. So action count is 4. If agent is allowed to move diagonally, then movements could be more than 4. Reward is a number that machine tries to maximize. Positive reward, negative or 0. Reward is a feedback from the environment. In chess game, reward received at each step of the game. In maze example, 0 is for no movement or no action. For positive movement, for shortest path reward 1, and for trap or circular motion without reaching any destination or taking same route again and again, negative reward. Assign reward for a given behavior, and over time the agent learns to reproduce that behavior in order to receive more rewards. A positive reward encourages the agent or robot to take similar actions. A negative reward or penalty discourages the agent to take the previous actions. Environment. Environment is the world the RL agent interacts with, that is the game or the moments that you are teaching robot to win. Policy is the strategy that an agent uses to select an action. Policy is represented by pi symbol. Policy defines from all available actions at the current state, choose the action that maximizes the expectations. Assign reward positive point to improve training. Is this good reward? Minimize loss by assigning 0 or negative values. Try to maximize rewards and minimize penalty or punishment. There are several RL algorithms. The most popular RL algorithm is Q-learning. There are other machine learning algorithms like supervised learning, unsupervised learning. These algorithms work on labeled data and unlabeled data. They predict outcomes and patterns but does not work in real-time environment. Reinforcement learning works in real-time environment, hence this RL is used in developing AI agents and agentic AI systems with a human feedback loop. Let us move to the next slide. Let us understand the advanced version of reinforcement learning, that is reinforcement learning from human feedback RLHF. RLHF combines human feedback with reinforcement learning. In RLHF, human curated responses guide the AI model like large language models LLMs towards more accurate and secure output. Let's say we have an AI model LLM that generates multiple text outputs for a set of instructions. Human evaluators then rank these text outputs based on factors like completeness, relevancy, accuracy, and bias. These rankings are translated into scores. Higher scores represent better completions. Let's try to understand this with an example. You asked an AI chatbot or a voice assistant, say Google Voice Assistant Gemini, to help you understand how to use Bluetooth feature on your mobile phone. There are several ways a voice assistant can respond to this query. Response 1 from voice assistant. Here are the steps to use Bluetooth feature on your phone. Click on Bluetooth icon on your phone. Select the device you want to pair it with the device. Select the file to transfer. File gets transferred. Second kind of response from voice assistant. This response attaches some personal touch. The response is something like this. Sure, I'll help you with the steps to use Bluetooth feature on your phone. Please click on Bluetooth icon on your phone, pair it with the device, select the file to transfer, transfer file, and so on. And then the response would be, I hope this response helped you. In second response, there are words like sure, please, I hope, thank you. These are polite words used in response to by a voice assistant. This adds some personal touch, more human-like response than a robotic voice response. That is response 1. In this case, the reward model in reinforcement learning with human feedback RLHF guides the model to generate more polite responses by assigning good ranking which translate to higher scores to polite output. As we saw in the previous slide of reinforcement learning, the reward and penalty, a reward model in RLHF is trained using a dataset curated by humans. A reward model learns the desired patterns to improve the model performance. The reward model is trained with human preferences for better results. In agentic AI systems where AI agents work autonomously by taking decisions without human intervention, human in loop can be added to AI agents to make AI agents smart by seeking human guidance based on situation. Let's understand reinforcement learning from human feedback with a real-time situation. A self-driving car encounters a roadblock and confused about the choices on the next move, whether to take a U-turn, move straight, or wait till roadblock is cleared. A notification from the GPS map sent for human guidance. Then human guides the next step and the self-driving car continues the journey. Another example, an AI agent can read the mails and draft a reply and directly send the mail by fetching the sender list from the address book. The process is completely automated. There could be some situations where the email composed by AI agents need to be approved by a senior manager before broadcasting the mail to the team. In such cases, AI agent sends notification to the senior manager for approval, and once the manager approves the email, AI agent calls the necessary tools to send the mail to the recipients or the team. In next slide, let us look at the improvements that reinforcement learning from human feedback offers over reinforcement learning. Data. Data in reinforcement learning outcomes are based on historical data, that is data trained over a period of time. In RLHF, outcomes are based on real-world priorities. Scalability. RL is easy to scale as the process is automated. RLHF lacks scalability due to human intervention. RL focuses on efficiency. RLHF focuses on both efficiency and empathy, the polite words used by agents while replying to customers. Example words like thank you, sure, please, etc., which we saw in previous slides. RLHF policy guides RL engine to learn human ranked responses to balance efficiency and empathy. Speed and experience. RL focus on speed. RL can make faster decisions than humans, but RL has historical data. It cannot consider the risk factors and edge cases to align with the situation and the context. RLHF focus on the situation and context, analyzes risk and edge cases, and with this experience, RLHF provides outcomes. Applications like fraud detection using reinforcement learning can minimize the false positives. But reinforcement learning with human feedback validates if the outcome is really fraud. RLHF can also assign the severity levels to the fraud based on the validation results, whether it is a false alarm or not. Thus, RLHF improves the accuracy of the system. If the AI agent or the application you are developing needs empathy, real-world situations and context, then implement RLHF, otherwise use RL. Pair speed, situation context and empathy, policies of RL and RLHF to deliver at scale with real-world priorities to earn customer trust. Now let us have a quick recap in this slide. Reinforcement learning. This prioritizes speed over experience based on historical data, focus on empathy, focus on efficiency. So what's your answer? Answer is reinforcement learning prioritizes speed. It is based on historical data and it focuses on efficiency. So answer is A, B and D. Next question. Which of these is not RL concept? State and reward, penalty and action, status and react, agent and environment. Agent, state, reward, penalty, environment, actions and policy are concepts of RL. So A, B, D are correct. Therefore answer C, status and react is not correct. So answer is C. Last question. Reinforcement learning from human feedback. Reward model is trained with human preferences for better results, cannot identify risk, can identify edge cases, all the above. In RLHF, reward model is trained with human preferences for better results and it can identify both risk and edge cases. So answer is A and C. I hope you liked the video. Please like, share and subscribe to the channel. Let me know your comments. Thank you for watching. See you in the next video. Until then, happy learning.